Good morning, sir. Myself, Sainath, along with my friend, a teammate, Anvita Reddy. Today, I here to explain you about the topic that is mastering the tic-tac-toe with reinforcement learning, strategies and techniques for training an AI agent. Now, let's have a look at the introduction part. So, what does this paper particularly deals with? So, this presentation and paper explores and gives you an example and gives you an insights into the reinforcement learning techniques and strategies, which will be helping you to train an AI agent to master the tic-tac-toe game. And also we shall cover here various strategies and techniques that can be employed by the agent to maximize the reward as well as to play the game. So this particular game, Tic-Tac-Toe, is a very simple game, yet it involves many strategies that have to be taken out by the agent, and also it involves making decisions based on the current state, which will affect the previous state and the future state, because the present state decides the future state of the game board. And also it helps you to serve as an excellent domain, which gives you an insight to apply various reinforcement learning techniques to train the AI agent. So, when we talk about this topic, there should be two different domains, that is problem and as well as the solution. So, let's see into it. So, basically, the main objective of this paper or this project is to train the AI agent, which helps it to play the tic-tac-toe game using different reinforcement learning algorithms. Specifically, when we talk about algorithms, we are using here SARSA and Q-learning. So, by implementing these agents and providing them with a learning environment, we require few answers, right? So, let's see that. So, basically, what is this we are doing here is that we shall be implementing two different reinforcement learning algorithms. As I said before, one is SARSA and the other is Q-learning agent. We shall train these agents on a large number of tic-tac-toe games. So then, after the agents are completely being trained, then we shall be, comparing their performance to that of a normal human player. So by comparing these two, we should also investigate the effects and the benefits of different hyperparameters on the performance of these particular agents. So after that, we shall then believe that this project will provide valuable insights into the use of reinforcement learning for playing tic-tac-toe game.
Now let's go ahead and talk about training the agent. Here, a gentle overview. We trained an AI agent to play tic-tac-toe using special learning techniques. How is it going to work? The agent played many games against a teacher agent to learn the best strategies. Learning process. The agent received the rewards based on game outcomes and improved its decision making abilities. Exploration and exploitation. Coming to this, the agent balances exploration of new actions and exploitation of learned knowledge during the training. Here in this project, we used the two main training algorithms. One is SARSA, which is SARSA, State Action Reward State Action Algorithm. So the agent learned by looking at the state of the game and moves it made. It updates its knowledge here in the SARSA algorithm by knowledge based on what happened after each move and the rewards it's received. Going ahead, the agent tried to make new moves sometimes and used what it already knew other times. Coming ahead with Q learning algorithm, it learned by looking at the state of the game and the best moves it could make. It updates the Q values based on maximum expected future rewards for the next state. Now, let's go ahead and look at the implementation for a clear explanation of what we're talking about. Train the agent to play against us. Let's do this by giving the command python play.py because it's in the file py. And here we are going to specify Q. You can even specify the flag as S, where it will train the agent based on the SARS method, or you want to do it Q, you can give it as Q. And now let's save it in a pickle file. Let's say my agent path.pkl. An agent already exists, and let's overwrite it. Now, here you can see a prompt that you are the X and the agent is O. Let's go ahead and start the game. Let's go ahead by doing the first turn. Now you can see it's prompting us to give a position. Let's give position, let's say 1, 1. And now you can see the agent playing with O. Let's go ahead and give other position 0,0. Now you can see what's happening here. Now here you can see the player winning against the agent. It's because the agent is not yet trained well. Let's go ahead and play once more. No, let's give the agent time to automatically teach. So you can do this by giving a command Python EQ. Here the flag is set to 5000. So here it just tells us that the number of game iterations to train for is 5000. During training, the teacher agent guides the learning process by occasionally following the optimal strategy, whichever we show to it, and making the random ones. So here by giving this command, you can see that the agent has already paid the games 1000, 2000, 3000, 4000. So here you can see that the agent has played 5000 games. Now we are hoping that it will give us an optimal strategy to not win. Let's go ahead and play once again. You can give the command Python play.py, setting the flag to Q, and let's play once again. Let's go ahead and play first. Let's use the same strategy we applied earlier. Now you can see the agent already playing better. Let's give position 2,0. You can already see what's happening here. It's blocking our previous strategy. Let's go ahead and give 1,2. You can already see it blocking us. Let's go ahead and give 2,1. You can already see what's happening here. So here, it's a draw. Now we can see that the agent performed well. Sometimes it will even outperform us and win the game. Here you can see that clearly we have trained the agent, and after the 5000 iterations of it playing the number of games, it has technically performed better than previously. We can keep on improving by trying continuously by training the agent. Now let's go ahead and see a plot which will show us how it's gonna get improved. Ah, sorry, I gave the wrong command. Now here you can see a loaded trained agent from a pickle file and plots which is showing the cumulative reward history. Here you can see the technical improvement. It will provide the insights into the agent's learning progress and performance over time. You can see how well it's performed. So this is the basic implementation of our project. For the better understanding, let's understand the strategies. The AI agent used different statistics to win in tic-tac-toe. It blocked the opponent's moves. It created multiple opportunities to win. It also controlled the center of the game board. Now, what happened exactly is it learned from the experience. The agent got better by learning from its past games. Playing agent game against humans. The trained agents could make smart moves even when playing against people. Learning for bigger games, the agents can also use their knowledge to play more complex games. Moving ahead, we can see role of exploration exploitation trade-off. The teacher agent sometimes made random moves to help the learning process. The agents found winning strategies by trying new moves and also using what they've learned by balancing exploration and using knowledge. It also avoided bad strategies. This approach stopped the agents from getting stuck in not so good strategies.
So next we shall discuss about the impact of training parameters. What are the impacts? So we shall see that. We experienced with different training parameters such as learning rate, discount factor, and exploration probability. So what is that? In reinforcement learning, training parameters are used to control the learning process, as you know. So some common training parameters include learning rate. What is learning rate? The learning rate helps you to control how much the agent's policy is updated after each experience, So in this case, a higher learning rate will cause the agent to learn faster than a slower learning rate. And also help you, it may also cause the agent to overshoot the optimal policy. So as I told you before, a lower learning rate will cause the agent to learn more slowly and it may not be much more stable. So next, that is discount factor. So the discount factor is like how much the agent learns from the future values. Agent values the future rewards. A higher discount factor will cause the agent to focus more on long-term rewards, whereas a lower learning discount rate factor will help the agent to focus on short-term rewards. And next is exploration probability. So the exploration probability controls how often the agent explores new actions. So higher exploration probability will cause the agent to learn more or explore more, whereas a lower probability will help you to, explore less. So adjusting these parameters can affect the learning speed and convergence of the RL agents. So as I told you before, a higher learning rate will cause the agent to learn more faster when compared to a lower learning rate and will help you to agent to overshoot the optimal policy. So at the end of the day, in general, a higher exploration probability will lead to faster initial progress, while a lower exploration probability will result in more exploitation of the learning strategy. It is also important to experiment with different training parameters to find the best combination for a particular run. So, Sean, now we shall discuss about the conclusion part. So, in conclusion, we have successfully trained an AI agent to play the tic-tac-toe game using the above-mentioned reinforcement learning techniques. Even though the implementation of the SARS and Q-learning algorithms, the agent has to be, has to learn to make optimal decisions based on his past experience and receive rewards during the training. So in this case of a tic-tac-toe game, the agent's goal is to win the game, right? So the agent receives a reward of one for winning, a reward of zero for drawing, and a reward of -1 for losing. So here the agent learns to take actions that maximize its expected reward. So the two algorithms, that is SARS and Q learning algorithms, are two of the most popular reinforcement learning algorithms. Because here SARS learns a policy which is a mapping from states to actions. Q learning is like, it learns a value function which is a mapping from states to expected rewards. So in this project, we implemented both the SARSA and Q learning algorithms to train an AI agent to play the tic-tac-toe game. We also help to train the agent in a way on a large number of games against teacher agents so that it can learn from the human level project. So after the agent were trained, we evaluated the performance against both the teacher agent and the human players. So at the end of the day, overall, this project demonstrates the power of reinforcement learning in teaching AI agents to learn and understand and make intelligent decisions in a complex game environments. Either it could be tic-tac-toe, either it could be any other game. So at last, the success achieved in training the tic-tac-toe agent opens up possibilities for applying similar techniques, as I told you before, similar techniques to any other game, you know, and solving real-world problems too that require decision making and strategy.